Okay, for 11.3, we are learning about the areas of polygons. You probably have learned how to do this in the past, maybe in 7th grade math with polygons, but let's name really quickly some of the properties of a rhombus so it'll kind of help you remember how to do area. So some of the properties of a rhombus, I hope right away you saw how this was marked up and you remembered that it has 4 congruent sides. And the other thing is, you may have forgotten this from our quadrilaterals unit, but the diagonals intersect in a very specific way. They intersect at right angles. So the other thing I want you to remember about rhombuses is, rhombi, whatever it is that the diagonals form right angles. Okay, so if you know that there are 4 congruent sides, you know the diagonals form right angles, that's really all for right now I want you to remember about a rhombus. So let's go over here and look at a kite. Some properties of a kite: it does not have 4 congruent angles, but it has 2 consecutive, remember what consecutive means? It means like those 2 and then those 2 right after it, so following. So 2 consecutive congruent sides. So that means these 2 are congruent and then followed by these 2 that are also congruent, but not to each other. Just the 2 are congruent to each other and then the consecutive other 2 are congruent to each other. And then the only other thing I might bring to your attention is, once again, these diagonals. So the diagonals form right angles. So diagonals form right angles. Okay, that's going to be important because what I want you to know about the area of both a rhombus and a kite, they're going to be the same. So, and this is the reason. Area of a rhombus or kite, go ahead and put this. The reason an area or rhombus of a kite is you can divide a rhombus or kite into 2 congruent triangles. Okay, think about the shape that we formed with their diagonals. You can divide them up into 2 congruent triangles. Okay, and those 2 congruent triangles would have, with base, the base we're going to call D1, diagonal 1. The height of each of those is going to be half diagonal 1, parentheses, half diagonal 2. And then if you put that all together, it would actually be 1/4 diagonal 1 times diagonal 2. So, I mean, I'm sure you're putting all this together, so let's go ahead and do the formula now. If I'm going too fast also, or writing a little bit too fast, you can always pause the video and make sure you get all this written down. So here is, let's go back to now the actual formula. Here it is. The area of both a rhombus or a kite is half times diagonal 1 times diagonal 2, or diagonal 1 times diagonal 2 divided by 2 if you don't like the half. But this is your formula. This is the one you need to memorize, become very, very, very familiar with. And here's what I was talking about. You can divide them into 2 congruent triangles, kites or rhombuses, and that's all that we wrote right here is basically putting into words what this picture has done for us. So look at the picture, make it make sense. Okay, let's come over here and compute the area. First, we've got a rhombus, and then we've got a kite. So remember, this is going to be very simple. It's just area equals half diagonal 1 times diagonal 2, or diagonal 1 times diagonal 2 divided by 2. So that would be half diagonal 1, which will go with 6. Diagonal 2 will go with 8. You're going to put it into your calculator. Half times 6 times 8 is 24, if I did that right in my head. Meters squared. Area is always square meters. So there you go. All right, let's move on to the kite really quickly. Again, The area of a kite is half d1 times d2. Half, we're going to say d1 is, it doesn't matter, 10, and then d2 is the one that's 7. Put it all together, half d1 times d2, I think that's 35. Hope that's right. If not, at least you know what to do. You're just going to follow this formula. I think that's right. Okay. Let's go down here and talk about really quickly a regular polygon. The word regular means that all the side lengths are congruent and all the angles are congruent. So it would be like your most perfect hexagon, you know, your most standard perfect pentagon, for example, or a square would be regular. So regular has all same sides and same angle measures. The center of a regular polygon, the center, if you're looking at this picture, and the radius of one, those are both in its circumscribed circle. So basically, if you put a circle around the edges of a polygon, the center would go out to the edge of the circle, and it would go to the corner of a radius. So let me put both of these, this and this. So both of these are the center. And radius, I mean, this one's the center and this one's the radius. And radius, but what we're talking about is of its circumscribed circle. Circumscribed. The word circumscribed means inside of a circle. So it's on the circumscribed, what's inside of the circle. Circumscribed circle. So we're going to start looking at circles, but polygons within the circle. Okay, the apothem is really important to know. The apothem is from P to Q in this picture. So it's from the center dropping a right angle down to one of the sides. So it's the same thing. Apothem is the same thing as altitude. Back whenever we learned it in triangles, the altitude drops into a right angle. So does the apothem. So the apothem is the height to the base. The height to the base of an isosceles triangle. And it has to be of an isosceles triangle because the sides obviously are radiuses that would be the same length. So it has to be of an isosceles triangle. And speaking of which, I just said this, but that's supposed to be has, two radiuses. Actually, that's pronounced radii. That's the plural for radius as legs. So it would have to have two of its legs as a radius from the circle to the corner, and the apothem is the altitude between those in an isosceles triangle. Okay, the central angle is the angle formed by two radiuses, or radii again, by two radii, such a weird word, drawn to consecutive, whoops, not a Q, consecutive, sorry, not an ELA teacher, vertices of the polygon. Vertices of the polygon. Okay, let's talk about what that means. So you have your central angle, which would be the angle formed by two radii. So it would be like angle MPN. So angle MPN is considered a central angle. It includes the center as its middle point. So angle MPN or angle NPM is a central angle because it's an angle off of the center. Essentially, that's what that means. Okay, let's come over here to this picture. What is special about triangle ABF over here to the right? So what's special about it is two of its sides are radiuses, radii. I don't know why that's so hard for me to say. So it's an isosceles triangle. So two sides are radii, so it makes it an isosceles triangle. Okay, now that we know it's an isosceles triangle, we can solve for all these different angles. So the measure of angle AFB, that is a central angle since it's off the center. So we're going to say that the measure of angle AFB equals 360 degrees, the whole triangle, divided by 5. Think about why I put divided by 5. This is a central angle. It would make one here. It would also make one here. It would also make one here. It would also make one here. And it would also make one here. So since this is a pentagon and it has 5 sides, there would be 5 central angles off of it. So we take the 360 and divide it by the 5. That would be 72 degrees. So there's our answer for that central angle. This would be 72 degrees. The measure of angle AFG, that is like half of the 72. So we can just divide 72 in half. And I hope you can see why. The whole central angle was 72 up here. And so if we want just AFG, that's half of it. So we just take 72 and divide it by 2, which would be 36 degrees. Okay, and then that leaves us with measure of angle GAF. G to A to F. So we're talking about this one. So this one is a little bit trickier, but I know you guys can figure this out. Let me just give you this quick review. Triangles add up to 180. Okay, we have 36, we have 90, so we're just going to subtract from 180 to get this last one. So we have 36, 90, and what? So we're going to take 180, subtract out the 90, subtract out the 36, and that is going to leave us with, I think I did the math right, 54 degrees. It's important that you know how to get each of these little individual ones because that's going to come into play here in just a minute with our last 3 examples today. Okay, let's go back to our last, I would consider this still vocabulary, and then we'll get into how to solve them. So if you have any regular polygon, and again, remember regular polygons all have the same side length and have the same angle measures within. So, excuse me, here is your formula for that. To get the area of the whole polygon, you're going to take the area of one triangle and you're going to multiply by the number of triangles in it. So if you just take how many triangles are inside here and multiply by the area of one of those triangles, then you have the area of the whole hexagon. So that's how to do it, and here is your actual formula for that. So area equals half times S times A times N. Let me talk you through this. Half, because it's a triangle, S is going to be the side length. So S is going to stand for the side length. So if it gives us the length of the side, that's what S is. A is the apothem, or the altitude. So that's how long this is. And then N is the number of sides. So in this one, since it's a hexagon, it would be 6. So if you know what each of these things stand for, you can find the area. So all I did was I took the area of one triangle, which is like half base times height, and I multiplied by the number of triangles, which is N. But it's written like this because that works for all shapes, and it's a little bit shorter. It just kind of sums up what we're doing. So some people put that the S and the N is the perimeter because it's the side length and then the number of those. So I've also seen it written like this. You might also write this down. I mean, it's okay. I probably won't use this very often, but I've seen it written like this: half of the apothem times the capital P, which is perimeter. So I'll probably use S and N because that's side length and number of sides, but that's also the same thing as the perimeter. So anyway, I'll probably mostly use this formula for area of any regular polygon. Speaking of which, we have 2 to try. So letter A, it only gives us the apothem. Letter B, it only gives us the side length. So we're going to solve these in 2 different ways, and you are expected to know how to do both. So here we go. Let's go ahead and just write what the formula is. I'm going to use half SAN. And let me review with you as we go through this what each of those stand for. So half is just going to be half. S is going to be the side length, and we don't know that. So we are going to leave it S. A is the apothem length. We do have that. That is 8. And the number of sides we also have. 1, 2, 3, 4, 5. This is a pentagon, so this is 5. I'm just realizing my S's and my 5s look a little bit alike. So, yeah. Sorry about that. Okay. So here is what you would do. You just do, oh, and that's to equal A. We need to know the side length. So here's what I'm going to do. I'm going to make just bear with me here. I'm going to make this triangle off to the side. So I'm going to try to find some space for it. Where am I going to do it? I'll do it up here. So this triangle is the same thing as right here. And the apothem is 8. So we know this side is 8. So here's what we know. We know this side is 8. We know this is a 90-degree angle. And we know we're looking for how long this side length is. So I hope right now your brain is going to trig a little bit. And we can also know how many degrees is up here. So right up here, remember how we figured this little half of one part? We measured this whole central angle as 72 because it was a pentagon, and lucky for us, this one is also a pentagon, and so it's going to have 5 central angles, and each central angle divided from 360 gives us, okay, so 360 divided by 5, we did this above, we got 72, and that's how big that angle is, but we only need half of it. So up here, we have 36 degrees. So I want you to go to trig, and I want you to be thinking tangent, because we have a 90-degree angle, we can use trig. Tangent is going to be opposite over adjacent. So from our 36-degree angle, it'd be x over 8. So we're going to do tangent of our 36-degree angle equals x over 8. And that is how we are going to get our side length. Well, at least half of it. Remember, we're only right now calculating this part. Okay, so I'm going to put that in my calculator. Tangent 36. Tangent 36. Remember, x is being divided by 8, so we're going to multiply by 8. And I got about 5.8. So 5.8, I guess we'll do 1, 2, 3. 5.8, 1, 2, 3. It doesn't matter. About. Okay, so remember, that is what just this part of our side length is, and we need the whole side to count for the S here. So I'm going to just leave that on my calculator and multiply by 2 because I need the whole side length to count for our S. So I'm going to round that to, like, we'll just say for today 11.6. It doesn't tell us what to round to. So I have now a side length of about 11.6. And now we're not missing any information, so we can just go ahead and calculate that straight across. We have half of our side length, so 0.5 times 11.6 times 8 times 5. And we got a grand total of about 232. I know it depends on what you're rounding to, but you should have gotten something close to this. Your homework will tell you what to round to, so just pay attention to that. And since we're calculating area, area is always units squared. It didn't give us what the unit is, so I'll just put UN. There you go. All right, last one. This is an example of one where you're given the side length, but no apothem. So we're going to have to do some trig to figure that out too. Okay, so we are going to do area equals half times S times A times N. Okay, and that would be half stays half. Side length this time we know is 10. Apothem we don't know. Number of sides we can count. 1, 2, 3, 4, 5, 6. Okay, so now we're going to have to take a minute and calculate the apothem. So what we know is there's a central angle in here. And from that central angle, we're going to have to come up with the apothem that forms a right angle. So if we know that the central angle is divided into 6 central angles, we can take 360 degrees and divide by the 6 angles. And that is going to be 60. And we know that we want part of that. We're going to use just this triangle. So part of that is going to be 30 because I divided it into half. So we have a triangle over here that is a 30, 60, 90 triangle. You guys are very familiar with those. They have their special rules. So we're going to try to find the apothem, which is the altitude. Okay, all we know is that the whole side length is 10, so that means part of it, this part of it is going to be 5. Because since the whole length of the side is 10, we're looking at just this right side of it, just this half of it. So that would be 5. And we're looking for this. So in a 30, 60, 90 triangle, let's think. The short side is x. The long side is x root 3. That's just a given in a 30, 60, 90 triangle. So if the short side is 5, then our x is just 5 root 3. So that's easy enough that we didn't have to calculate anything. X is 5 root 3, so our apothem is 5 root 3. So we're going to put in our calculator half times 10 times 5 times root 3 times 6. Okay, and we're just going to put it literally exactly in our calculator, exactly like that. So I'm going to do 0.5 times 10 times 5 root 3 is just 5. You can literally just type it in exactly how it looks. Or you can put a multiply in between, either way, and then times 6. That equals about 259.8. So our area is 259, we're rounding this, 259.8. We don't know the units, so just units squared again. Okay, keep these notes handy for when you get to your practice assignment today.